Morning lads, another video to keep you updated on the progress. Since the last video I've made this PCB circuit thingy-doodle here. It does three things. This is the protection circuit, so if the cathode current goes over 1 volt, which is 100 milliamps, and what happens is it trips this triac, which will, through a convoluted route, it'll turn on this relay, which cuts the negative 240 volt supply, which will turn off this big transformer. That's supplied by this, I can't see there, can you? That's supplied by this transformer down here. The power supply to that, obviously that transformer goes into here. This half-wave rectified into these. It's just a 1N4007 diodes there. That half-wave rectifies it. So I've got split rails here, plus and minus 15 volts. We're just using the plus 15 volts to power this here, which powers that triac. Also, does your hand in. Also, we've got a peak detector here, a clipping detector. Right. So at 6 volts, which comes off the, sorry, just rest this a minute, it really hurts my hands. We've got 6 volts coming off this anode here of this ECC83. At 6 volts, this will make this LED come on. That's clipping indicator. And then we've also got a VU meter driver here. 6 volt comes in from the same source, so here's our voltage off our anode through this cap. Goes into the clipping indicator here. Through this 100k pot. I had to put the 100k pot on because this 10k input resistor was loading the circuit down too much. So that's just there just to give a bit of higher impedance. And then we've got a TL074 quad op amp. I'm only using 3 of the op amps. What that is a precision rectifier. The first one, which uses these 2 diodes and a couple of resistors, an amplifier and a buffer, and that'll drive this meter here. A lot going on there on that circuit. I've just done it how I usually do it. It's not the neatest way of doing it, but it's quick, and that's just to use a Dremel. Where are we? Just use the Dremel to cut out all the traces. Like I say, it isn't neat, but it's quick. I really must have a go at doing chemical chloride. I think it's chloride, isn't it? Yeah, whatever, etching, at some point. But a lot of the time when I'm making these PCBs, I haven't to lay out to start with, although I do work out some of it on paper. I'll just work it out as I go along, make a few mistakes, but it works. So that means that there's a bit more wiring that's to go in here. Wiring for this LED here, wiring for another LED, which I'm just doing now. That's to basically, that LED comes on when this triac turns that relay on, so that'll indicate a fault indication. I did have a blinking, where are we? Did have a blinking LED, but it stopped blinking. So what I've got now, I've got, just for now, a really, where is the bloody camera? Really bright white LED. What else have I done? Oh right, this is the wiring here. Basically comes off this sense resistor that monitors this, the cathode current of the output stage L34s. That's taken me quite a while to do. Other thing is I did have a pot clamped to the side here that I was applying negative feedback, and as I said in the thread, I applied negative feedback, great, everything was working well with that pot, and as soon as I basically replaced the pot with two 2k resistors, there's 4k on there, so I'm not applying a hell of a lot of negative feedback. I don't know just how much at the moment. It started oscillating, which I will show you now. Pause. Okie dokie. Now we've got. Alright, turn it on. There we go, relays clicked. That's a soft start. Signal generator. What this here is, I've just, you'll see in a minute, that's just connecting these capacitors here. I've got about 1200 microfarads reservoir cap. I'd read that put in some smaller caps in parallel at the anode supply of the output stage would get the high frequency off the HT and you know, what's it to ground. Sorry, I'm not explaining good things very well here. Right, here's the output. See if it does it. The bugger ain't doing it. Right, well, what it was doing before, what was happening was that when I got to about 25 volts RMS on the output, which is what, about 60 watts, this the output would do this, bouncing, and the bugger's not doing it now. Really typical. No, it's just going fine. Oh, so what I did, to stop that, I just, you know, took the ground connection of those two caps off. Oh. This amp, honestly, it's very fickle. Alright, okay. It was doing, I'll show you what it was doing. It was like doing that. Alright, let's put this fans on. Talking of fans, just leave that on there a minute. Talking of fans, I've been going through my fan box. I've got quite a few of these, well, not quite a few, I've got a few of these, where are we? Micronel fans. Obviously got really nowhere to put them. Can't put it on the back, can't put it on the bottom, so thinking of putting them in there to get rid of some of the heat. I've got those two, they are 24 volts. Problem is that there is nowhere in there to put another transformer. No, not even a small toroid. There ain't nowhere, because as you see, I've got I bought another toroid which I've got to unwind and then rewind again. So a little bit different size to that one, but we've already got a power supply in there. There's just nowhere to put fan. I've got some other ones like these ones. You know, they shift, they're really good fans. Silent, shift a load of air. I've got some really tiny ones. It's a 12 volt one, little Micronel one. Yeah, it's where do you put the blinking transformer, so I'm going to have to fork out for some soon and 250 volt fans, and they'll just go in there. What I'll do, when I come to build the top, there's going to be a small plate over the power supply there, and then a grill here with some holes in it and what have you, or maybe, I don't know, I'm just sort of talking out loud here. Fan on the top, and I'll make it so that it hinges up so this chassis comes out. As you can also see, I've cut some aluminium, thin aluminium, I think it's about 0.75 mil or something like that, sheet for the sides there. Chap on the forum is helping me make some of the metal work for here. Thanks, Mark. What else? Oh right, yeah, having trouble getting some screws at the moment. These screws are to screw this into here, into this woodwork, but they're too big. These are supposed to be 3/8, be 4, whatever 4 is. They look bigger than 3/8 to me, they do. So I've got to try and get some smaller ones to go in there. We can't have two bigger ones because these heads, as you see, like here's the small one I've used, and the head obviously has got to be countersunk. Well, with it being only a very thin alley sheet, you know, if you've got a big head, it means you've got a big countersunk and it's not really gripping onto a lot. What else have we got? That's it, I think I'm about there. I don't know why that bugger's working when it wasn't. I do not know. Strange. Just see what we're getting out there. Oh, that one is sleeping on, isn't it? Just pause you a minute. Checking the power output. Right, clip in there. That's full output. What we got there? 31. Push it a little bit more. Starting there, isn't it? 33 volts RMS output. He's quite happy at that all day. Later on I'm going to put the protection circuit in there and everything, and get the speakers outside and give it a try. Actually, just pause a minute. Right, so I've fitted the protection board, the clipping indicator, and wired it all up and all that. Just been testing it to see if it works. The protection works really well, too well. I had a problem with the clipping indicator not coming on, so I've got the old scope over there. There it comes up. Right, let me just monitor that to, come on, what we got? 2.3. Right, as you can see, there's the clipping indicator coming on. Also see the BU meter comes on, and then if you should hear a click when that starts to go into clip. It's about to go into clip now. There we go. That's now come on. That's basically that relay. Oh, sorry, that relay there is disconnected. The negative side, the neutral side of the transformer, mains transformer, and as you see we've got a bright LED here indicating a fault condition. As I said previously, I wanted to put a blinking LED on there, but that's the next best thing I've got. And although it's on, the amp's not going to come on, so we have to turn it off, leave it for a few a few seconds before turning it on. If anything though, mind you know, right, hold on, let me just turn it back on again. So I'm trying to think about what I'm trying to say, and obviously being aware of what I'm doing at the same time. There we go, turn it on, relay clicking, that's obviously clicking the resistors out there, shunting them out. Right, the only problem I've sort of got, right, I'm turning, this is the old, turning the volume up there. Right, so where are we? Trying to think here. Need something on there to indicate, don't we? Well, unless we... Right, so there's that comes up. That's indicating there that that's clipping. I haven't done the VU meter for FSD. Right, and that's come on there. You see what I mean? Look, we've got about, you can see that we've got about, well, it's clicked off about there. So what are we talking? We've got about 90 degrees of volume control movement before. What I'm trying to say is we've got 90 degrees of volume control movement after it clicks off. What I would like to get it to do is, you know, be able to crank it right the way up, then it comes into clip, and an actual fault situation to turn it off, rather than, you know, it just going there. So what I'm trying to get at is I need a different volume control to lower the amount of signal going into the input stage. Yeah, I'm gonna have to think about that one. At the moment there's 100k on there, so maybe I need a 1 meg. See, that 100k, I did ask a question about this on the forum. That 100k is in parallel with that 1 meg resistor there. So yeah, do you put a bigger one or smaller one on there? Yeah, don't know. Anyway, that's working great, protection works great. A little bit too sensitive though, maybe. That's clicking off, it should click off at 1 volt RMS on the cathodes there, which equates to 100 milliamps of cathode anode current, whichever. I think they're the same thing, aren't they? So I mean that's right. I mean, yeah, the circuit that I nicked it, you know, borrowed it off or nicked it or whatever, he had 15 ohm sense resistors on, which for a fault condition of 1.2 volts or 80 milliamps on the cathode current would click it off. But I mean, I've been running these, you know, quite happily with kicking out 130 odd watts, and yeah, obviously they're sort of pushing them at that. So 130 watts, let's call it 120 watts. So 120 watts divided by 3, 12 divided by 3, that's 40 watts per pair. That's pushing it, isn't it? Because they say 25 watts output per pair push pull is the max, and we're getting 40. Yeah. Anyway, something to think about. So what I'm going to do next then is tidy all this up, put it back as it should be, put it in its case, and I want to see that VU meter working with some music, which hopefully should be soon. So I'm going to stop this and I have to edit it, put it on the end. Anyway, shut up waffling.